Do you actually want to view my friends list? Incomplete. Close the Steam window. Because I don't want to dox myself. We've encountered the awkward bit of this game where it doesn't properly tell you how anything works. I've already forgotten what this does. How do my instructions work? How does this work? Which is one of this game's flaws. This... I don't even remember what this does. You can't muck around with this, is the other problem. There's no instructions, right? Right, because this has 4 save values, 4 output pins, an address pin, a save pin, and a load pin. And it isn't entirely clear what that means. I guess if we put an 8-bit constant... Well, that can be 1. This can be 2. And this can be 3. If we step, nothing happens. So what I want to do... What does this do? Nothing. So If I change the width to... It like... So we write, if we're writing a constant 0 to the address, it doesn't... These are all 0. Okay, so then it wrote 16. So what are these for? It writes 16. But what is not... What does this do? That doesn't write 16. I don't... Okay, so I understand what the how the data width is working. So then we're reading 16 from there. So these other 3 pins... We put a counter on there. It writes 16. And it just reads 16. Oh, and I try to... Okay, so we crash because I'm trying to read access outside the RAM. Wait, unless... No, that's a Boolean pin. So as far as I can tell, right? Like, this thing, right, is outputting 4 bytes at a time. But it's not clear why it's doing that. And it isn't clear... Yeah. And ideally, I'd probably want to rebuild this entire thing. And if I do the component factory... I'll put RAM in the component factory. And then we realize that there's no way to track this is one of the other problems with the game. And how are conditioners working? Opcode. What's the point of this? That's gonna... And we have the problem that I've already forgotten. Where the hell do I put this? Guess we put it in somewhere in my documents. The fact that I'm having to make a new text document. Leg instructions.txt. Select an app to open this txt. Oh wait, you know what? Hang on. Let's get Notepad++. Wait, but I could just use VS Code. Now that I think about it. Okay. Extensions. Okay. We're going to attempt to sign in. Use my password. Well, hopefully this is my password. Signed in, unfortunately. Oh, I don't have any of my extensions. Okay, right, well, this sucks. What do I need? Prettier. Let's install that. Now, it's... I don't have all my VS Code settings. This is the problem. This is probably my password. Oh, it's not my password. I'm not signed in. I really should. Alright, which Gmail is this? The wrong one. I want to switch ad account. Oh, wait. I have to click next before I can enter my password. 2FA, check your Google Pixel 3a. Yes. Alright, new password. Wait, but I actually need to go back to VS Code. Log in. Right, there we go. Extensions. Where's the restart extensions host? How do I restart the extension host? There we go, restart the extension host. Log into Windsurf. Open. Right, we've logged in. I don't. There are probably other VS Code extensions that I will need to get. Windsurf is useful, but we have the issue that settings, format on save. This is gonna suck. We're not. I'm not. I cannot be bothered to. I'm just. How do I? Just gonna download Notepad++. Choose an app on your PC. Notepad++.exe. There we go. We have a text file in Notepad++. Right. Why was I doing this? Oh no, that's the old one. Okay. Okay, right. I'll put this on here. This is me, right? This is one of the problems with this game, right? I'm essentially having to I'm having to take notes in a separate file because trying to remember what all these opcodes are. I mean, I guess I could program them in. Right. Wait, seriously? Let's see, line feed. I could probably also change tab spacing, and there's a show hide, which looks very strange, but let's leave it on for the moment because I always like show hide. Right. So we've got, except this isn't what they mean. I'm going to rebuild this, I think. What's 32? Because what we're actually thinking about it is we have these 3 bits, which, and again, if I want to look at it, I have to go back to opcodes, right? So if this bit is unset, we're in mathematics mode. How are you supposed to... No. This is the problem with this. It's incredibly cryptic. I'm sure it said at some point. What if I wanted to copy data? I guess if you wanted to copy a... Because there's no convenient way. It doesn't tell you what these are supposed to do. I guess you do it with immediate values? So I guess this moves the value from register 0 to register 2. Wait, what? This puts 9 there. And we subtract 123. Then we AND it with 0. Right, 0. So this just should put 32 in the counter. I guess. It's always the same. Yeah, so if you wanted to put the input in register 0, I guess you would just add 0 as an immediate value? Which seems silly and like a janky workaround. So we have to ignore bits 7 and 8 for the opcode. Because they mean something different, right? It's more like here, if bit 7 is set, if it's bit 8, or is it bit 7? If bit 8 is set, we use this differently. Well, we still only have 3-bit register addressing, which means I want to use the 4th one as RAM, for RAM, like I did before. Of course, this might not work. I want to get a copy of the actual the leg. Hey, someone got to listen. Someone's messages. Don't know what happened. Don't know what it was. But oh, here we go. Basically, and the other thing is, and my brother would not be happy about me doing this. To me, when I think about, if I just look at an input, I can't set it. Okay, whatever. Basically, this is the value 32, right? And then 33 for the, like 34 and 35 for the conditionals. For me, I find it easier to think of it as this bit switches it into conditional mode, and then we just have the same however many bits. Why is this a 60? Who knows? I don't understand what's going on here. Conditionals. Right? We essentially use... Actually, I could look at the... Yeah, these 3 bits tell it what conditional to do. And this bit is acting as a toggle. Why is it turning this off? Why is it turning that off? What even is this? So this is the decoder. Oh, because we're not saving, we're just jumping. So I find it easier to think of it that way, right? Where the actual opcode, basically we have maths opcodes. Basically the way in my head I find it easier to think of it as saying, okay, these bits do something else. This bit is telling you whether we're doing maths or a conditional. But I would think, can I not upgrade it so that I have a true and a false as well? Because if you wanted to execute an unconditional jump, I mean, false is a bit useless, to be honest, but if you wanted to execute an unconditional jump, you would, I guess, say, like, if immediate 0 equals immediate, or you could just do, like, if reg 0 equals reg 0, which is just... I appreciate that it's more efficient to do that, because it doesn't... It means that the computer is less fundamentally complex, it has less stuff in it. But from a programming perspective, that's just slightly confusing. It slightly obscures what you're actually trying to do. Basically, I would say jump is more clear than if like variable equals, if my variable equals my variable, jump. Right? So here you go. This is an if false. Well, okay, no, it's not, but... It doesn't look like it actually ever does it. No, it never actually does the unconditional. So if you wanted to just make a looping program, you would put in an instruction here. Like, if equals... If reg 0 equals reg 0 would be your unconditional jump, because that condition is always true. But to me, it would make more sense to have it be able to say true, even if that technically, like, doesn't matter. The bit 6 is unset. And then the last 3 bits... Right, that's basically how it works. So this is... So then we have... It's not even maths. I'm calling it maths. And then this is just looking at the last 3 bits, right? We're doing it like this because this looks mono, just totally monospaced. Because I know how to, you know. Right? That's what they do. I'm going to leave it largely the same. How many, yeah, this is going to make things awkward, is the thing. So basically, do need full stops here. And then again, we just use the last 3 bits. Oh no, we have to care about what mode we're in. Is it a literal jump target? See, this is the thing. We only have explicit jump targets. We can't do dynamic jump targets. In fact, this is not capable of dynamic jump targets. Does it need dynamic jump targets? They would be potentially useful. Because then you can do dynamic jumps. right? Right, so this is basically the actual way it's set up in the game. Of course, then you get to RAM, and I have to write the code myself, so we'll see how I go about doing that. Now, the thing is, right, if byte 0 is an opcode, it uses... But these 2 bits are completely unused. Right? So I could put flags in them. And for me, I want to use this one as a flag, similar to how these ones switch the... Oh no, this is nonsense, because the result would never be an immediate value. That makes no sense. However, it would make sense to group them, and essentially, I think it wouldn't necessarily be useless to have... Oh, no, this isn't very visible, is it? I should probably move... You actually can't see what I was doing. I'll move myself down there. This bit is switches to conditional mode. I could have it be this bit, switching to conditional mode, and that way I have this free, and the idea would be that by setting this bit... Actually, you know what would be easier for demonstrating this? Let's get this, and then I can do it here. So if I use this... So basically, this bit toggles the... I'm going to wire this up, so I can actually set this. So this is... I can just set the instruction. So this is add... This would put it into subtract. That's... Oh, I've lost my instructions. I need those over here so I can actually see it. This is sub. No, this is and. Have I skipped the number 3? How did that happen? Okay. So that's and, that's or, that's not, and that is XOR. Right? If we set this, it switches to conditional mode, right? This bit, and then we use these 2 bits for equals, not equal, less than or equal, greater than or equal. This bit, if it's set, causes us to use the second byte as an immediate value. This is why this swaps over instead of a register address. So there's a value coming out of here, but we're ignoring it. This bit causes us to use the third byte as an immediate value instead of a register address. But what I could do is, if we use this bit, I mean, of course, it's I mean, I might have to rebuild this again. It's like, oh, no, actually, we're using this. If this bit's set, we do something else. Is why I would have preferred it to tell me everything I'm doing at the start. If this bit switches you to conditional mode instead of this bit, then this bit could say, like, but normally when it would only matter in conditional mode. Unless, of course, no, actually, well, I could do something different. Basically, in conditional mode, normally, you use the fourth byte as a jump target. Okay, if we're in conditional mode, we would use this fourth byte, goes in here, and gets written to the program counter, which is being, which is being, I don't know what I'm doing. Oh, because I'm comparing the input or something stupid. So this would treat that as a direct address in just a program ROM address. But if I did it like this, you could surely say use it as a register. That would give me dynamic jumps, right? So if it's like this would be this would be jump to the value in register 0. But this would be jump to address 0, because then you use this bit, this byte as a raw jump target. That seems to me to make... Can't. Right? That gives you additional behavior. The other thing you could potentially... I mean, for maths mode, obviously, because the result... This is an address of a register. So I guess it does. It means it's unused when this is unset. If we use this for the second one, right? If we're in immediate mode, obviously it's just a raw value. But if we're not, this is register 7, which is the input and output. I think there are 5 registers. Oh no, 6 registers, 0 to 5. 6 is the counter, and 7 is the input and output. But then there's this bit, which is unused, unless when you're not in an immediate value. So I could do the same thing I did before, where say, if this is set, instead of reading the value in register 7, which in this case is obviously the input, read the value in RAM at the address that is currently in register 7. So, I mean, this would be... It's that one. Is it that one? No, it's this one. Yeah, of course it is, because we have a 0. So this means read the value in this register as your value on the input, on the first input line. But then this would hypothetically be, look at this register, and then um, use it as an index and then look at that and whatever the value is in this register, use it as a RAM address and just address, like, read the value in RAM at that address. Obviously, it would be undefined behavior if you tried to read RAM on both lines at the same time. And then the same would be true of the second byte, of byte 2. Obviously, this is byte 0, obviously. If you tried to address RAM from both, you would get garbage, because you would be trying to write two different... Hopefully I can... Well, I did it before. Basically, you'd be trying to write two different RAM addresses. Two different values to the RAM address line. And then for the third, for byte 3... Oh, because this, I was going to say, I need to be able to do this. I would need to be able to do the same thing for byte 3. Then you need like an additional output. So this is these, and then they would need to have another pin. Although they wouldn't actually need to have another pin, because I could also just use... Basically, you need to be able to save to RAM, otherwise RAM is completely useless. So the point would be, and the same on the last byte. This would be save whatever result you've got to register 3. Or yeah, that's register 3, because obviously we've got register 0. And this would be read the value in register 3 and save the result of your operation to that RAM address. Although... Hang on. Can I cheat here? And do this? No, not that one. This one. Okay, we could do that. because I can read two bytes now. But this is supposed to... yeah. So I think I can use the overture. So I'm going to, because I think it'll be funny to use the wrong thing. I will find it slightly amusing to use the wrong thing. So what I actually need is... Not that documents. What am I supposed to do? I need to... I've already forgotten how this works. Let me check. The destination is always stored in the lower nibble of the upper byte. So what I would actually need to do is we will... put 1 in val 0, and then we would need to... put 32 in there. Right? And then the idea is to... This would be a target. I just want to do this to see if my overture architecture... Let's see how much of the game I can beat with the overture architecture. Because that's funny. Because I programmed 16-bit instructions in. And then... Yeah, I should have implemented jumps and labels, but I never did. So the point is, so we put that in there. And I am actually going to write into RAM back from the end, because it makes more sense. I might have an off by 1 error. Then basically the idea is we copy So the idea here is these have to initialize, then... Oh no, I have to put this in somewhere. So I actually have to go for... something, which I haven't worked out yet. Then we need to... Um... 3, and then I need to work this out. Here, 1, 2, 3, 4, 5. This starts on line 5 and it's 8, so I subtract 1 and double it. This starts on line 9, so 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, so yeah. This is wrong. Oh, it didn't finish, I think. Yeah, okay, it crashed. It's reading the... Oh, it's in release. This is what, so it should be good im. Destination is val 0. Right now we should have a copy instruction. That was the copy instruction header. Wait, the condition has an extra bit? Yeah, it does. So this is actually coding assembler times 64 release. So let's see. I think this will work. We put 1 in there. Oh yeah, I want my supposed to do. It's supposed to put 1 in this register. Then it should put 32 in this register. Then it should put 8 in this one, and then 16 in this one. Then it should copy a value from the input into RAM, which it did. And it should then subtract 1 from this, and then jump. I believe it should. Now it should not jump. And we should write 32 to here again. Then you don't need the leg architecture. What? Wait, so this has... If I were to do this... This is a delay score of 2. So I need a 5th gate. So yeah, I'm just cheating by using the wrong architecture because I built a good architecture, so I can just use it. What are we doing here? I've got to multiply two 4-bit numbers. How do you multiply numbers together? Wait, we just add them. So these are... How do we... I don't really care about my score. To be honest. Where are my bit shifts? There they are. Okay, well, this... I could build something kind of hideous. The basic idea, right, is that I'm going to take this, and then we first basically this pin doubles it, this pin quadruples it, and this pin octuples it. So if this pin it, so we need to bit shift it by 1, by 2, and by 3. So basically, I need 3 of these. This will bit shift by 1. Simplicity, we will use these. For consistency, because it doesn't appear to impact my score. Then the basic idea is to go and then I'm just going to add them up. Is there really nowhere? Huh. That looks close enough. Right, okay, so that's 0 times 0. If we do say... That's 2 times 1. I think this just works. Right, so we just do that. Yeah, got an achievement. Oh, I got a... Yeah, I got... I'm not showing that. I got an achievement for using no more than, like, 3 adders. Implementing the stack. Wait, hang on. You're changing your queue to be first in, last out. Are you insane? That makes absolutely no sense. Where's my stack? Create a stack. With RAM, I guess. I can't decrement the counter. Wait. I can Okay, here's what we're gonna do. We're gonna build a sequential RAM chip. Is my idea. So this is my address line. Hang on. You can't simultaneously push and pop. That would be nonsense. Well, it doesn't tell me which way to do it, surely. If you try me to push and pop, but simultaneously tell me to push 3 and pop, do I push the 3 and then pop it, or do I pop something and then push the 3? And it doesn't tell me, so if it matters, it's bad game design. So basically, my thought process is, we have a counter. No. We have a register. I don't have a custom register, which means this is a pain, because we always want to be addressing the RAM. Right? I suppose we wire the input directly up, and the output also directly up, because all we do is tell it whether to read. Right? This is the simple part, right? If the input is set, we enable the save. If the output is set... Oh no, hang on. Input... Oh, input. So this is pop. So if this is high, we save to RAM. This is the pop input. Right? So the difficulty is keeping track of this. So basically the idea is we start at 0. I want a custom component really, not the issue with the counter is that I can't have it it doesn't have a disable pin. There's going to be if I've been off by 1 error here probably. So this is keeping track of my RAM address. If we assume we don't I don't think we ever would be not loading. Right? We always want to read. We always want to set the address. And then we have this adder. Is there a better way of doing it? Use... No, I actually have to use an adder. So you get this adder. But then I will need 1 and... Wait, the 8-bit constants are irrelevant. So this is 1. And this is -1. And then I need one of these gubbins. Really, I also want to save every time round. Actually, we'll use these. So if we push, we need to increment it. I mean, this feels like it might work. Let's see what happens. What? It's loading 0. Do I need to subtract 1? I think I do need to flip and subtract 1. She's going to make this really, really ugly. We're going to bring this out here. No. Wait. No, I think I need a not gate in here. No, we don't. We just do it like this. Okay, so we're starting our RAM. Your components were saved to the component factory. It's so awful. I need to fix this. Although does it wrap? It'll wrap. That's hideous, and I love it for that. There is the issue that I don't understand the programming thing. Integer divide two numbers. I don't actually know how you do integer division. Well, I know one way of doing it. Is there a better way of doing it? So, I know a way of doing this. Right? Yeah, okay, so I'm gonna have to rebuild everything for this. Unless we might still be able to do it. There is... The method I know, repeated subtraction. Where have I got a command window open? Because of debugging. Basically, you take... I love this jank that I've made here. You would take your input and then you repeatedly subtract. So basically, the idea is you take 29. In fact, that's the wrong one. I need... Yeah, I'm using them. So basically, I want to open this file. Send to my... Wait. Send to my phone. No. Right, so what the method would be something like that. Obviously we're going to need that. And then I'll have to immediate some jumps. That's for now. It's a placeholder. And then the line feeds. Edit preferences. Tool settings preferences. Because character turns, or they never, all they ever do is cause problems. Wait, which one do you get first? Because that's actually vitally important. The numerator. right? And then val 4 is going to have to be our counter. Oh, I haven't got proper comparisons here. This is the issue. I can't. All I can test is if it's. This won't. This they may have come up with a solution. Basically, this will break. This only works. This has to assume that everything's signed. Oh no. We could do it more concretely. So basically, the idea is we will check if the denominator is greater than our, essentially, we're going to repeatedly subtract the denominator from the numerator until we hit something smaller than the denominator. So we need to check if our current total is smaller. So we're going to subtract the denominator from the numerator, and we put it in register 4, and then we need a condition if it equal. The thing is, I need to do whether this is greater than. If it's negative, then we've gone too far. And where do we jump to? I should put labels in. This would make this so much easier. So then we jump to val 1. Otherwise, we want to kind of finalize the subtraction. So we want to do that. I'm going to have to use register 6. Which is my last one. And then jump. Which is going to be back to here. I think. And then this is my other jump target. Where we're supposed to output the quotient first. The quotient is in this might work. I'm not sure, to be honest. Let's see what happens. So the idea was we put 1 in there. We're putting 20 in there. Putting 10 in there because that's the most sensible place to put it, obviously. Then we're putting 10 in. And we put 10 here. And then we should put 3 in there. Then the idea is we subtract 10 from 3 and get 7. And then we should check if it's less than 0 because it's actually... Hang on. Oh no, we subtract 3 from 10. We get 7. So we should now... Yeah, we put the 7. We didn't jump. And we counted 1. We should... Wait, program should jump. And we did another 7 minus 3 to get 4. So then we've got 1. And we should do... Copy that over. Now we should do 1 minus 3 at some point. And get minus 2, which is 254. And then we should jump... program counter. Yeah, there we go. Yeah. That I was expecting that to happen. So do I have... Well, could use a 16-bit register. No. Yeah. Yeah, the issue here is that my algorithm... Well, that needs to be fixed, doesn't it? I mean, this is hideous, but like, what are you going to do? Slightly better. Is there a... this takes 2 inputs is the problem, and I don't have any space in the my updated the instruction does not have any, basically, what is it? The condition doesn't have any space because it needs to put a target somewhere, and it only has, and then the second byte holds, the upper half is the value to check, and the lower nibble is the is where the jump target is. I could fix this by dumping values in. I mean, basically, that I could implement this by, instead of checking if the value is less than 0, basically I need to implement I need to fix the other one. Basically, the idea would be, I could use bit 5. You see, we like, right? That's basically the idea. Then, because we only need to use 3 bits as a register address, we have 5 other bits to do other stuff with. Right? For this, we have 5 bits spare. So the idea here is that in basically what we do is and then yeah. Yeah. So this is my improved version. Do it like this is the idea. And how do you... that? So I can, if I edit this here, say by drawing a squiggle, then it's there. So is this going to be 6 registers? A program counter and the input output? Wait, this one actually does have an unconditional jump because you can just write to the program counter. I guess. How the hell does this thing work? Does it actually work? And what the difference is. And there is still absolutely no indication of what the extra pins do, and I couldn't work it out. I don't think... Well, I mean, I could, I guess, have... I mean, here's the thing, right? I could make a system that works... Oh, wait, it would be... What does this do? It wrote a 1. So I still don't... From an address size larger than the RAM. That's the annoying thing. Yeah, it all comes out on there. If I put it in there... What I... I don't understand. Like, what if I set this to 2? If I set it to 3... I cannot work out, is the thing, what on earth... 256 these 3 pins and these 3 pins do. Writing to these doesn't seem to do anything, and these never seem to output anything. I think the issue... Right, I'm basically going to have to redo this, and I'm going to have to redo the... The question is, right, how many memory... How many registers is it going to have? I'm going to actually have to start using the RAM. That's why I guess I'll have to build a new assembler. It'll need to actually keep track of RAM addresses, I suppose. Guess we could start. I was tempted to call it ARM, but then that might actually get confusing because ARM is a thing. So, okay, so the question really is, what am I doing with RAM? And do I want 16-bit support? I could probably just upgrade the thing by replacing all the parts with 16-bit components. The issue is, right? We calculate the RAM address. If the difficulty is writing to RAM, I could define a copy, actually. Well, I don't quite know why you would ever want to look at the program counter. In fact, reading the program counter is necessarily useless? Because, okay, let's see, right? If we were to read the program counter, we get 0, which is the address, which is this instruction. 8, 12, 16. We're about to jump, but currently we're at instruction 16. Now execute this instruction, which is located at index 24, and we're reading 24. So surely this is necessarily unnecessary, right? Because, for example, here, when this instruction runs, the program counter will always be at the same thing. So I don't see why you would ever need to read the program counter, essentially. Or at the very least, well, the program counter at any particular point in the program is defined at compile time, as it were. So I mean, this is obviously in the other one. This is in the for the overture improvement thing. Like if in this instruction, which is bytes 8 and 9, the program counter is at 8. We might be updating it, but we won't be able to read the new. Wait, this one. Oh, sorry for this one, because this one then. So is at 12. This is bytes 12 and 13. Program counter will be at 12. We might be setting it to 20, but we won't be able to read that 20 until here, at which point we've jumped. So if we tried to read the program counter here, we would be reading this load value here. So you can see here, right? It's being updated to 32, which would be this updating it to 20, but it's still reading 24, which was the value on the previous tick. So unless you update the program ROM, and I don't want to I'm not in the mood for trying to implement like I can put RAM in the component factory now. That's going to make things a lot easier because it'll be... That's a lot smaller than a RAM chip. Oh, although I guess we use a dual load RAM because that way I can read from 2 RAM addresses at once. Can I go for... How big can it go? Like... How does this... Can I use this? Like... What's the point of the ROM? Oh, is it used in like... How do you... Can you edit it? It seems completely pointless. Unless... I don't know. I don't know why it keeps dumping the display everywhere. Yeah, the other thing was writing to the instruction counter. Seems also pointless. I guess it would allow you to add... Basically, because there's no copy instruction. Like, I would potentially go for... Like... a move instruction. And I can't... You can't do comments in text files. That would be... That makes no sense. And a... We don't need a false because because a false doesn't do anything. These would be help because obviously for a true we just always jump. And a move instruction would be, the point of a move instruction would be to just, I want to copy the value from the input into a register. Because otherwise for simplicity, you could, and I could set up the, basically you could use the assembly, but it would be helpful in terms of writing the assembly code, I feel. I would think I would find it helpful to be able to write, because otherwise, if I wanted to move a value from the input into register 0, I would essentially be like, or the input with 0 and put the result in register 0. Like you OR it with 0, or you could AND it with 255. You could subtract 0, you could add 0, you could XOR it with 0. But being able to write move value to there would be clearer than... basically, if you write add, it should indicate that you're adding things. And if you're not actually adding things, you're just moving something by adding 0. It's a bit... In the same way, you'd end up with doing if value is equal to itself, or if 0 equals 0 using immediate values. Jump. Which means we would end up with 7 registers, 0 to 6. Oh no, but the... But this would allow you to arbitrarily jump, because you can... Yeah, if you wanted to put something into the program counter... I guess the only use for having the program counter be effectively a register is that you would be slightly far... It would require one less instruction whenever you wanted to write. You could write to it without a jump instruction. But saying... Did I do a multiple? Of course, the question... Okay, it tells you lower half and upper half. So I could also implement... a multiplication would be potentially useful. And I probably want to leave something for divide. But the ability to move can be left to the can be left as an implementation detail. As in the actual assembly language would have a move instruction, but it could be implemented in any way that because obviously adding 0 would do the same thing. But the only I guess multiplication could be useful. Yes. Although having said that, I do have a spare bit. Because, and I said that basically this bit puts you into conditional mode. And then these 3 bits control the so this is maths. This bit is spare. So I do actually have potentially 16 different... I do have another bit of space. We're going to leave this out for now. Do we need the true? Yeah, I don't feel like we need a register for the program counter. This. What does this do? Oh, does it... It probably persists between runs. And you ought to... In my opinion, you should be able to edit it. Same... Basically, like, with the... What does that even do? Oh, I guess that's what it does. And then this does the same thing. Yeah. I don't understand how lowering delay by being slower. I guess it lets you lower delay score, but is slower, which is just like lowers delay by being slow. I don't know what fast RAM is, but like, it doesn't actually make it slow. I mean, okay, this is exceedingly expensive compared to this one, right? It's 30 times. However, I mean, this is a complete... It makes no sense. Yeah, it has 4 read pins, but none of them... But 3 of them are just dead. It's just very odd. This actually has 2 outputs as opposed to just output 1, output 2. Like, well, they don't do anything. Sorry, it's just... Unless you're supposed to go, like... No, but that doesn't work, though. Like, this would make sense, but that's not how it works. This is how it works. Oh, wait, no, I have to... I want to... I don't think that's how it works. No, that isn't how it works. But this is. So what is... What are these for? Who knows? But I guess I should probably muck around. I think this is what I'll do. Unless I want to put multiplication in. Because I can. Oh yeah, the issue is trying to work out how to... Now the question is, for my... Like, my register... The difficulty is, right, I know, I'm working out how I would want to implement this saving to RAM. Because I could essentially give it a third read pin. Or you could do it, I could do it with switches. And have it only turn on the one it wants. Which would be a way of doing it. That has a gate score of 8 and a delay score of 2. Let's say, hypothetically... Wait, where's... Yeah, there we go. So that's 72 and 10, right? Surely that... I mean, I could go for... We're happy with 8-bit registers. Yeah, and then we put this on here so that it has 3, and then this has no... Yes, basically, this has delay. This has a gate of 8 and a delay of 2, whereas... This has no delay. The Switch... There's 64 and 10. I don't really know why it's different, but it seems to be. This is kind of stupid. So what is this thing going to be? Right, so if it has, it's going to have the input and the output hooked up to it? Or is it? No. You would be unable. The problem here would be that you can't. See the RAM, which would make debugging horrible. Because the idea is I have a bunch of registers, right? And then we could. I put on save. Then you could. Right? It goes to 16. Oh, actually, presumably it saves to this address. Yeah, so it saves to address 1, which would mean that if you are writing to RAM, that's how we do it. Right? Because that would cause a problem. Because basically we're going to have a registers, blah, 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 and then if we're reading from RAM on load 1, so this, basically we have, I don't think I need this. Oh no, because we might be loading the value from one register. Load 1 will be the value of our first argument. Load 2 is the value of our second argument, and then load 3 is exclusively, basically, if we're loading, if argument 1 is being loaded from RAM, then we would pipe this load 1 into this first address bus to set the address, and then we would get a value out on here. If our second argument was coming from RAM, this bus would go into this address bus, which would set the second pointer, and we get the answer out on there. If we're saving to RAM, we will pipe this bus into here to tell it where to save to, and then we will pipe our save value into here. But we might be reading from this RAM. Basically, well, we could be reading from one register, adding the value to another register. So we're adding this value to this value. And then if we want to store the result in RAM, we would need to be reading this bus on the third register, because we've already switched on. We only want one. We need 3 read buses from the registers. What are my inputs going to be? We would need. So this takes like 3 bytes as input. And will output. Basically, this whole mess is the memories. It's not keeping. Doesn't need to keep track of the program counter. It gets told. The only case is that we need a pin to disable saving, because it may well. Because the conditional still reads 2 arguments in. So it needs a pin to disable the saving. And then it will need 3 byte. I've got no water. 3 byte inputs for addressing our first argument, our second argument, and our save address. A save value input, and then it will just have 2 outputs, because it will only ever output 2 things. The third load output is only internal. It'll also need to expose, I suppose, the input and output. It doesn't have a... So I need to... Wait, this is unnecessary. Didn't I just go... What did I... Which is one that I solved with that? This probably doesn't work. I think this is where it'll break. It ever uses the input again. Doesn't look like they... Let's try this, right? Okay, this one, let's say hypothetically, you replace this with an on. I think this will... Zero three. If I were to put this in, which would be immediate the value 0 into a the first instruction is immediate the value 3, immediate 3 into a register 0. This might break. So yeah, the thing is, do I actually... I guess it's going to have to expose a this as the input, right? Put that there. It will have to expose this as an input. And then also expose... this. And the point is that this... So because you then have the... you do that. So that this can turn that input on and off. Yeah, these outputs will essentially be like this. Wait. Like that. So this goes high if it needs if the thing is supposed to read read the output. But then what does it need? It needs like 8:15 and a delay of 6. It'll be much more efficient than putting a whole, although but there'll be switches everywhere. Just it'd be easy to just put an extra decoder in. So let's start, I guess. So this is our 3 addresses, I suppose. And a save. This would be like load 1 address, output 1 address, output 2 address, save address, save value. I need a save disable pin though. Right? Which gets set when it's unconditional. Because we have to disable the saving. Those. So this would be the save value. This pin is set. This is going to be big, but probably smaller than it would be if I built it in the level. Yeah, but presumably... Yeah, I don't want the program counter in here, I guess. We do need to be able to disable the save explicitly, though. Basically, it's just gonna... But the point here is that we can disable the saving of everything. But we also need to decode this. What was I thinking? Basically, this is just save value, so that's not going to get in the way. This pin indicates that we are saving to RAM. This bit. Unless this is set, in which case we disable everything. So that makes more sense for this to be the address into RAM. And then the difficulty is that these need to actually... I might do that and then transition to there, and then I could put all the registers down here, and then the memory will be a really weird shape. But I'm not really bothered about that. So then the idea, I guess, is that... Means I need to be able to access these, which is why I'm thinking... We do this. That won't work. Instead, we go... The RAM was also going to have to go somewhere. Yeah, this just gets... And then, of course, I can go... Which is a thing. This looks much more complicated. And therefore is better. And the basic idea, I guess, is to say... There needs to be a data bus. Which, per tradition, is going to be pink. Problem that you can't see what any of the pins are. You just have to know what they are, I guess. Right? You can see the values in the 7 registers, but you can't see what the pins do. And the fact that it's disjointed is very jet. The ram's going to end up going somewhere. There's more. We need an input. Now these have to go somewhere. They have to stick off the bottom, probably. We're going to number them from left to right this time, because that will make things so much simpler. Actually, I could put a bunch of... Because ideally, I just want to put the RAM in here. I'll put them up here. Because this is going to go on the right hand side. And it's just going to have a bunch of inputs and then the outputs are going to come down here. So if the input goes up here, which will mean I can connect it in very odd ways and run cables through it, but that's fun. And then again, this is... They probably want to go there like that. I need a third colour. I've forgotten why I was doing this. I forgot what the third colour was for. Oh yeah, no. We're changing up our colour scheme, I guess. Let me check what's important. Um... Get a lag spike when it reconnects. Right, now I need to handle the input. So basically, if we have an input bus coming in from up there, the input could be hooked up. Because theoretically we could save to the RAM address in the input. So I need. Which one's which? This one is. Okay. I'm eating, so goodbye.